Hello everyone, welcome to today's video. Today, we'll be diving into the fascinating world of software architecture, specifically focusing on a revolutionary approach known as microservices. Microservices, to put it simply, is an architectural style that breaks down an application into a collection of small, independent services. Each of these services corresponds to a specific business capability and can operate autonomously. This approach stands in stark contrast to traditional monolithic architectures, where an application is built as a single unified system. As we navigate through this topic, we'll be discussing the numerous advantages of microservices, such as improved scalability and agile development. We'll also be touching on the challenges and considerations that come with implementing this architectural style. So buckle up as we explore the ins and outs of this modern architectural paradigm. Now, why are microservices gaining so much attention? The advantages are compelling. Let's unpack these benefits. First off, scalability. Unlike traditional monolithic architectures, microservices allow for independent scaling of each service. This means you can manage resources based on demand for each service, rather than the application as a whole. If your user base grows, you can simply scale up the services that are under the most strain, rather than the entire application. This leads to more efficient resource utilization and can save significant costs in the long run. Next, let's talk about agile development. Microservices facilitate continuous delivery and rapid iteration. With smaller, focused services, development teams can work independently on different aspects of the application. This modular approach enables faster development cycles and quicker responses to market changes. It's all about delivering value to your users faster and more efficiently. Lastly, we have resilience. This is a big one. Unlike monolithic architectures, where a failure in one part can bring down the entire system, microservices are designed to be resilient. Each service operates independently, so if one service fails, the others can continue to function. This design contributes to overall system stability and availability. Failures in one service do not necessarily impact others, contributing to overall system stability. Of course, it's not all sunshine and rainbows. Implementing microservices comes with its own set of challenges. As we delve deeper into this architectural style, we encounter the intricacies of service coordination. With an array of services communicating and interacting, orchestrating their operations becomes a critical task. It's like conducting an orchestra, ensuring each instrument plays its part at the right time, in harmony with the rest. Next, we confront the challenge of data management. In a microservices architecture, data is often distributed among multiple databases. Managing these databases and maintaining consistency across them is no easy feat. It's like piecing together a jigsaw puzzle, where each piece represents a different dataset. The aim is to form a clear, coherent picture without losing or misplacing any pieces. So, while microservices promise many benefits, they also demand careful consideration and planning. This is a critical aspect that developers need to address. To make the implementation of microservices smoother, various tools and technologies come into play. One of the key technologies is containerization, which packages up software code and all its dependencies, so the application runs quickly and reliably from one computing environment to another. Docker is a popular platform used for this. Then there's orchestration. This is where Kubernetes enters the scene. It's a system designed to automate the deployment, scaling, and management of containerized applications. A perfect match for microservices. But what about communication between these services? That's where API gateways shine. They manage the requests and responses between the microservices, ensuring smooth interaction. Monitoring is another crucial aspect. Tools like Prometheus for monitoring and Grafana for visualizing the data help in keeping an eye on the health and performance of the system. Companies like Netflix, Amazon, and Spotify have successfully adopted microservices, experiencing benefits such as improved scalability, faster development cycles, and increased system resilience. As with any architectural approach, microservices have their patterns and best practices. Communication patterns such as REST or gRPC are commonly used, creating a language of interaction between services. Best practices include strategies for versioning and updating services, crucial for maintaining a well-functioning system. Looking ahead, the future of microservices is bright. With emerging technologies like serverless and edge computing, the landscape of microservices is evolving. As technology evolves, so does the landscape of microservices. Stay tuned to see where this exciting architectural approach takes us next.